This is Between Two Firms, and my name is Mike Wrinch.
And I'm Graham Lovely.
I'm from Hedgehog Technologies.
I'm from MCW Consultants.
We both do electrical engineering, but we do
love it.
Oh, and we love it.
Don't we?
We do love it.
Oh, thank God. Mike, I'm so glad we could get together for this first episode of Between Two Firms.
Graham, me too. Being from Hedgehog and you from MCW, two electromechanical engineering firms.
Yeah, that bring a lot to the table on really important conversations.
Yeah.
And I think one of the most important ones that are really facing Canada right now is about electric vehicles and supply of electricity. Energy is all around us. We need to solve some of these problems.
One of our favorite topics.
It is, and especially for two engineering nerds who have dedicated their whole lives to try and figure this kind of stuff out. It's not easy, and I think you've dedicated the most time to this. What do you see some of the biggest issues right now in trying to get EV cars in every garage?
Well, okay, so I have an EV. I like my electric vehicle. Do you have one?
I have a hybrid. I have a plug-in hybrid electric vehicle.
So why hybrid over EV?
Because I live in a condo building that was built in the 70s, and I knew that it was going to be really hard for me to get charging capacity and charging capabilities in my building because I get assigned a parking spot. Definitely nobody thought of this 50 years ago when they built my building. So the size of the service and everything else isn't ready for it. So I thought, well, I better hedge my bets, and I can't go for a full electric yet.
You're using a buzzword there, service. What do you mean there?
Right.
Service, that little plug right by your car. What was that meant for?
Well, at the moment, that little plug is meant for a block heater.
Block heater.
Yes. So some cars that go up north have block heaters to get the engine warmed up so that they don't, so that they can start properly when people go in them.
Or vacuum.
Or vacuum.
Right, but a charging station is 10 times that, easily.
Oh, absolutely.
So it wouldn't, those plugs, maybe your one plug would work,
Yeah, that's right.
but if everyone along your area did it plugged in, it wouldn't work at all.
Well, and so as you talk about that, it's important for us to remember that a service to a building is what I was mentioning, and you kind of twigged me on, is the addition of all of the energy, all of the power usage in the building, and what that average amount of energy consumption would be at any one particular time that needs to be delivered by, in our case, from the utility BC Hydro, and then distributed down to where it's needed the most. So the service is from the street, from the utility, and then branches out through a distribution network to get to where your car is.
Right, and most of our buildings were built in the 50s, 60s, or 70s. And
Sure.
what do we have? Lights and a stove.
Basically.
Right, now we have huge TVs, computers, video games.
Absolutely.
Everyone has a computer.
And residential consumption of energy is traditionally very low. So you know this world better on the utility side. What's going to happen if all of a sudden we want to go in and plug in electric cars everywhere? Can we do it?
Can we do it? At every level, really. Like if you start at the local level, we're saying it's not impossible, but our local buildings may not be sized properly for everybody to have an electric vehicle.
Yeah, those service sizes, for example.
Which requires a major upgrade at your home. I have an electric car. I like my electric car for a lot of reasons. It's faster.
Yeah.
I like driving quickly or accelerating quickly, but I also like.
But you always abide by the rules, don't you, Mike?
I do.
Absolutely.
Most of the time, except when I'm late. But what we did see though is I put a power meter. I'm a geek, so I love measuring things, and I measured the power of my car, and I measured previously the efficiency of my old car, and my old car was a VW Jetta, which is a lot like.
That was my dream car when I was a kid.
It's a fun car.
Yeah, or a
good car.
Golf. I love the Golf.
That's
the hot hatchbacks.
Yeah.
Yeah. Carry on. Sorry.
And by using the measurement of the gas, the cost of gas versus the cost of electricity. And if you got an electric car for free, and you had gotten a gasoline car for free, the cost differential right now at gasoline prices is you would spend about 5 times less money in electricity than you would in gasoline if you had a car.
So it sounds like electric cars are a slam dunk.
I mean, they're
I mean,
cheaper.
if two electrical engineers decided to buy electric cars or plug-in hybrids, you'd think they were pretty much a slam dunk.
They're cheaper for two reasons. The operation,
Yeah.
because an electric car only has one moving part. It has a motor, like the turning motor,
Yep.
whereas a gasoline car has thousands of parts and lots of maintenance.
Yeah.
I don't know why, but I've owned my car for 5 years, electric car for 5 years. I've never taken it in for maintenance.
Not once.
No, there's nothing to fix.
See, that's completely crazy because we all grow up in a world where you have to go to your dealership
Right? Every year.
constantly every year, or go to your local mechanic every single year and do it. So that's a sea change, right? That's a huge shift.
That's a huge shift. But like you said, how far could I drive?
So this really, well, let's get into range stuff in a minute, but like this is really interesting. So obviously the overwhelming positive at the personal level for owning an electric vehicle is there. So you would expect that you could walk onto a car lot, buy your EV, come home, and then everything would be golden. But that's not necessarily the case because the rest of the infrastructure has to catch up to what that vehicle needs, that new, to use an electrical term, that new load, right? It's a load on the system. It's something that's consuming energy, and then we are using that energy.
Consuming
elsewhere.
energy, and on top of that, we're using, there's a lot of encouragement to use heat pumps,
Yes.
which from, so normally your heater uses natural gas. In some old cases, people used to use, and in the East Coast, they still use
Heating oil.
diesel,
Heating
oil.
oil. Yep.
And so when you convert to an electric thing, you use more electricity. If you get an electric car, you're using more electricity. And then in our case, our house had to be upgraded,
Right.
which cost thousands of dollars to upgrade the electric service. If you're in a large building, to upgrade your building, it could be hundreds of thousands of dollars that the owners would have to pay for.
So here's the piece that we need to really get across is, and we need to communicate this clearly, so engineers and governments and everybody and car dealerships and everybody have to, that there's a total cost of ownership piece to this that's very atraditional, right? It's not the same as having a gasoline vehicle where you've got your maintenance costs every year, and yes, you're buying insurance, that's the same, and you're changing your oil and that kind of stuff. You're not maintaining it every 5 years, but now you're taking what might be an equivalent or more amount of money and now putting that into your home, into the power delivery component, right? To get it to the house.
Yeah.
So how do we go through that? I mean, let's face it, we've got these buildings that are very old, their electrical services aren't necessarily set up for it. We obviously have to have a plan, right? You don't want to just start tearing wires out of your walls. Always make sure that you get an electrician, licensed contractors. Or you need to have an engineering study done so that you could do this on, say, a bigger building, right?
That's right. That's where engineers come in for the larger scale. But what I know people talk about, what's good and bad electric versus not electric. But I'll tell you my main reason why I like electric cars. And the reason is that when you're trying to control pollution, and I just noticed this because I just got back from a trip to China and I was in Shanghai. And I was there 8 years ago, and it was very thick pollution. You couldn't see some buildings across the street.
This was 8 years ago.
8 years ago.
Right, okay.
But I went just a month ago,
Yeah.
and it was clear skies.
Air quality's that much better.
Unbelievably different. And it's because buses, cars, 50% of the cars are electric. There's no
in the
more,
whole country.
Certainly in Shanghai.
Oh,
Because they have green license plates or blue license plate. If you have a green license plate, you're a battery-powered car.
So there's a huge push by the government to incentivize EV ownership to improve the environment.
Yeah, and it works. And the reason it works, and this is my point, is if you're trying to control pollution, can you control pollution having millions of little exhaust pipes from every single vehicle on the highway?
Yeah.
And the answer is no.
Distributed source pollution.
Or can you control pollution by a single smokestack?
Single point.
Which is a single point, right? And so I've seen what China did is yes, they still use coal power. We use, in Canada, some coal power to produce electricity. We have a lot of hydroelectric. But even if you do use natural gas or coal or oil to produce electricity on bulk, you can control the pollution because you have a single chimney.
we're starting to get back to the slam dunk on EV cars, Mike. I think from the perspective of the distributed pollution versus single point pollution, the ability to drive for less money per kilometer, all that stuff sounds great. So it sounds like the real holdup, the problem that we might have, is in that middle block between the generation and the final plug. Is that fair to say?
Well, yeah. I mean, we are sized for, we're at capacity right now, and we're sized
What
for.
size? We. Who's we?
Sized. Oh, the electric wires.
Yeah, okay. So
Wires getting here.
the energy grid.
The energy grid, the grid can only support so much. So do we have enough electricity for cars, and people want cooling in their houses now or in their apartments?
And that's always a tough one, because when we talk about energy and we talk about electrical energy specifically, enough is always a difficult word, because we think that there's a big giant tank of it and we're drawing it down or filling it back up. So it's hard to quantify enough. So how does that work? Because my understanding of utility has always been it's a balance of generation to load at any one particular time. So if we start pouring tons of EV cars on, what happens to that balance? It's not just like a tank where you constantly can just pour more in to fill it back up. How do you keep that?
Well, if we go out by layers, you have your home, and in my case, my house, I had to upgrade our electrical panels. In your apartment, you'll have to upgrade the electrical wires, all the wires
and
to
all the
support
meters
that.
and all the everything.
And then when you go outside that, if every building or every house on my street had an electric car that was charging every day, you add that up, and all the poles outside your house would then be overused, and they would have to be upgraded. And then if that entire block did that, everyone in that entire block.
So add that all the way up through the distribution network, and we end up at a power generation facility that then has to be sized accordingly.
Yeah, and
in order to have the capacity.
Yeah, and do we have that capacity for all of British Columbians or Canadians or North America?
And we know that obviously not everyone is going to flip over to an electric car right away. I mean, we've got some impediments there. You talked about range earlier, and I didn't want to get into that too early, because I think everyone really focuses on the range part. We talk a lot about the range anxiety.
Yep.
I only actually can get 25 kilometers on my plug-in hybrid before I have to recharge it. And I don't have to worry about that really any day. I can take my daughter to daycare, get to the office. Fortunately, I live close to my office, so that's super helpful. Obviously, there's a lot in that too, but if I were to be going and commuting back and forth to North Van, I could definitely do that, right?
Yep.
That wouldn't be a problem.
Yep. Most people's basic commute is short. Most.
Right. Which allows something like a plug-in hybrid on EV mode only to work fairly well.
Yep.
But I then have the option to go to gas later. But then I'm now relying on two energy infrastructure systems in order to manage my choice.
Right, so it's overly complicated, and you're still stuck in the car way of life. And you have batteries, whereas I just have batteries, and we have basically no maintenance costs, so other than, which I don't know the answer to this.
Well, and so I'm in this sort of funny system where I've been very practical in my approach to it, knowing that there are certain impediments, right, to getting, as you said, everything lined up, from the building to the neighborhood to the region, to allow my full electric car and all my neighbors to be full electric cars. I know we're probably a ways off from that yet. So I made a practical choice that, well, if this car is going to last me maybe 10 years, then this will be the right thing. And hopefully then we're in a spot where we have made the investment in the electrical infrastructure within the province, leveraging the fact that we have good, clean hydro, but getting to a point where ultimately we have the ability to step up this distribution system so that when this car is finished, I can go and get a nice new electric car.
Well, I did drive, there is a lot of infrastructure here. I drove from Vancouver to Bowring Lakes, which is, for those who don't know where that is it's a 9-hour drive from here.
Right.
And so...
And you had no problems?
Well, I didn't drive for all 9 hours, but I had to plan. So we had to plan. There's a supercharging station in Cache Creek, for example, and then so we would drive for 3-4 hours, park the car, plan it around lunch or something because the supercharger takes an hour
Right.
really to fully recharge the car.
We're still incredibly fast,
but
not
yeah.
by gasoline standards.
Not by gasoline, but I've heard that there's new batteries coming out that can do that in 10 minutes.
Unbelievable.
And
that'll be a game changer.
Yeah.
That'll be a game changer.
And that's all media stuff, though. Like, that's out of China. I haven't actually seen it.
Fair.
But it's like, it's coming. And so, okay, question this then. If I've heard a lot about solar panels being cheaper. Cheap, like, why don't people just go off grid? Like, put solar panels on your roof of your apartment and you're done.
That's a really good question. Because at the end of the day, you have variability in the ability to deliver energy. And one of the reasons why an electrical grid with standardized generation that is consistent 24/7 is so important is that you want to have that energy available right when you need it. So there's lots of layers that would go into having a photovoltaic system that would make sure that you could have 24/7 capacity unless you were both grid tied and feeding through photovoltaics.
I'm not totally following you. Like, do you mean, like, you just can't get, if you have solar power, you get no electricity when?
When it's dark.
Right, so it doesn't work in the dark. What about
Right.
cloudy?
It works, but it's reduced. So photovoltaic systems are improving. And you have a lot of experience with this, given all of the work that you've been doing with remote communities. And you know well that when it gets cloudy, the amount of energy is lower. It's a little bit less, consistent, right? And you do need to augment that if your loads at that time start to increase.
Well, in Canada, we have this problem is that the summers are long and the winter, long days in the summer.
Yes.
And the winter, you have short days.
Yes.
So you might only get 6 hours of light in Vancouver in the winter, and it's not sunny. Whereas in the summer, you get 16 hours of light.
Well, and that's
it's sunny.
assuming that it's not raining. And in Vancouver, I've never really seen it rain before. Have you?
No. Sometimes it does.
Sometimes it does. It rains a little bit in Vancouver.
In Canada, we measure our rain in meters. In Vancouver, that is.
Yeah,
so, you know Vancouver, how many meters of rain Vancouver gets a year?
I don't know.
It's about 2 on average.
2 meters.
2
of rain.
meters.
That is a depressing statistic.
I know. Some areas are in 4 meters.
But I'm from Vancouver.
A meter is
Island.
about a yard for you Americans out there.
But I'm from northern Vancouver Island, and so, well, it's really the midway, but we call it the northern end.
Yeah.
From the midway on the island, and if you think it rains a lot in Vancouver, you should try the middle of Vancouver Island.
See, now we're talking meters.
Now we're talking meters.
Yeah.
But nonetheless, so we have to try and have some kind of a balance to make sure that the energy needs are there, because we have a cultural expectation, right? That you can go and just flip on a light switch and your power is going to be there. Or you can go and plug in anything at any time, no matter what. You got a brand new skill saw, you got an EV charger, you got an EV car, you got whatever it is, big screen TVs you mentioned earlier. There is an almost uncontrollable amount of inputs on the system, on the electrical system at any one time. So what happens if, as you said, we put that photovoltaic roof structure on the roof and now we're tapped out?
So, okay, wait a minute. What if we just say we're not going to use much electricity?
So now we're talking demand side management.
Well, okay,
Okay,
so we're not using
no buzzwords. No buzzwords.
No buzzwords.
No buzzwords.
No one likes the buzzwords.
No buzzwords.
Okay, so we're gonna say
engineers get together. What do? They start chucking out acronyms and buzzwords.
That's right.
Yeah.
We're gonna say, like, okay, if you use,
It's
say you're
complication
saying
for
I'm only
obfuscation.
going to use electricity during the day.
Yeah.
That's all I want. And you've got just enough electricity.
Yeah.
And you have one of those beautiful days where the fluffy clouds are blowing by.
Perfect.
It's a beautiful sunny day.
I can see it.
Right? I love those days. And you're out there and you're using just enough electricity and a cloud goes over your house. What do you do? What can you do?
Everything sags.
Well, sags meaning the lights go out.
Not fully out, necessarily.
Yeah, okay. But they might.
They might.
Okay, so what can we do about that?
Well, we'll need some way to store some energy.
Right. So you could get a Tesla Powerwall
or I've heard of a thing called a battery.
A battery.
Have you heard of a battery before?
Like in your cars, batteries, storing of energy.
Batteries store energy.
Right. So we're going to store energy. So you can store the energy when you don't use it, and you can put a battery in.
Well, that's a great idea. But now this is starting to sound really complicated. So here we have an electrical grid. We have photovoltaics on a roof. We have batteries. And we have essentially uncontrollable loads. So is this the world that we live in? And now we still have to get to the root thing of trying to plug in all these EV cars. So if the solution is distributed energy in vehicles, and we have now distributed energy in all of these buildings, we're talking about a really cool concept, which is called microgrids.
A microgrid. That's right. So your house could become a little microgrid. And lots of people do it. People on islands, like Lasqueti Island is completely off-grid.
Yeah.
Everybody runs a little microgrid. And they're almost all solar battery systems. And they design their house around the limitations of that. And it works. But you have to design your house around it. And one of the beefs I have is that the building code, as far as I know, does not direct people to say, when you build your house, if you want to have backup power, battery, or even a generator, you should have a critical load panel, like an electrical station where you can plug in your backup power system. And you could disconnect everything else. Like, you don't need your dryer or your oven or anything. Like, where I'm talking, the power goes out for a day.
So your freezer. Because you've just invested in $1,000 of Haagen-Dazs and you don't want to lose that.
Right. So the freezer uses actually very little power. So you have your freezer there and you have your Haagen-Dazs. You can eat Haagen-Dazs.
Oh, so good.
You could have your salmon that you may have caught on some fishing trip, or your neighbor gave you a fish.
Fantastic.
Because they bought a boat and now they have too much fish because they've been fishing.
We'll talk about boats another episode.
Okay. But I got a boat and then I started fishing and I ended up with too much fish.
That's why I was we can talk about boats another episode.
It's a problem with
it's just my
owning a
nightmare
boat.
is owning a boat. But
You'll have too much
you have
fish.
one.
But then you need
that would provide that I like fishing. I don't like fishing. But we're off topic.
Right. The backup power, you have a backup panel, but or backup panel, when I say, is that the electricity comes there, you can easily plug in. That doesn't exist. No houses have that. Unless you are a builder and you're an electrical engineer and you want to have backup power, you'll build something like that. But it's never designed. And all the old houses, the biggest issue is retrofitting.
It is. And I mean, in my work, a huge amount of what we do and what we want to continue to do and what we really are emphasizing is trying to make our existing building stock last longer, right? So you can build a concrete structure and it's going to last 100 years. It'll last a long time. I'm no structural engineer. It'll last a long time. Let's just say that. Let's say with high level of certainty, it will long outlive the mechanical and electrical systems that are inside it. And I'm not talking necessarily the wires, and you can go into some old houses and the wires are fine and stuff like this. But over time, heat, which is the enemy of electricity, makes things brittle, right? Insulation and connections and everything else. And so it just doesn't last, right? Anyone has tried to go and buy a new electrical circuit breaker for their panel and realize that their panel has been out of stock, service, manufacture for 30 years. Well,
our panel was built in the 50s.
Yeah, there you go. Exactly.
And there's nothing we could do to change it. We just had to pull the whole thing out and put a brand new in it.
Absolutely. So that's a big part of our business, right? Is to try and make existing building stock come to a place where you can bring the modern world into it. And I think we've had such a thread through this whole entire conversation of doing exactly that, right? It's like trying to manage what is supposed to be connected and how the energy is supposed to be supplied to it, and then going up the chain so that now you have this sort of macro picture of what energy delivery needs to be for an entire area. But I want to go back to the microgrids because this is a topic that's really popular, and it's also very important for folks to understand that there is a higher level of engagement from everybody in society in order to make that work, right? It's got to be better education or more education for owners. Needs to be municipalities and building codes and so on have to be able to take that amount of energy coming into the system and not just coming from one point, from all of these other points. Manage it, regulate it, right? A utility has to be able to balance it, right? Their utility has to make sure that it's safe. because their staff and their team members are out there trying to keep all the wires going between all of these buildings and little microgrids.
And I think many of these problems have been solved. But like, here's a policy problem.
Well, that's a good one, because I think a lot of people are maybe under the impression that a lot of these problems haven't been solved. I think there's a perception out there that it is still 1972 in the built environment that we have.
Well, a lot of it is. But the difference is that if we're going to just focus on solar, for example, it's computer controlled, which means it's reactions, it's instantaneous.
Yeah.
They don't do what traditional dams do. They're smarter than that. They can be remotely disabled. They can be remotely turned off. And they're safe interlocks. We work in safety control systems. You can create what's called an interlock, which means it can't possibly turn on.
Okay.
And that can be done. It doesn't have to be right now what we do is manual switch and then a person locks it out. There are other ways to do it that are still safe. But I want to get back to like an issue that really, I'm going to use the word frustrates me, because I think we need to change this. Parking lots, okay? It's a single-use place. Like go to Costco.
Yeah.
You have a giant parking lot.
Yeah.
At least half of the day it's empty. It's void of anything. The rest of the day it's filled with cars and people running around.
Yeah.
Why is not the Costco parking lot part of the utility? Like, why doesn't, like...
Well, we need to have people with more EV cars.
Well, no, but
where's
like...
the power coming from?
Like, if we're not 100% renewable,
Right.
right? We're not 100% renewable. Why? And you have a hydroelectric dam, which people may have not thought about this, but a hydroelectric dam is the world's largest battery. You can turn it on and off second by second.
Kinetic energy.
Right? It just stores it in as water. So
It's physics at its very best.
yeah, so if you have hydroelectric, you have the hand. It's like having a royal flush,
Right.
right? Because you don't need batteries on a large scale. So then you could go Costco. Every giant parking lot you see, why isn't it policy that there is not solar on top of that?
I think that's a brilliant idea.
And just because we don't own it, like just say publicly it's not owned, that doesn't mean the utility can't broker a deal and make a deal that works for everyone but serves the public.
Okay.
Because the utility is a monopoly essentially, and it needs to serve the public interest.
Absolutely. And grid reliability and stability is their paramount objective, right?
Yeah.
I mean, this then gets into an interesting thing, and I want to try and figure out from you whether or not a lot of these ideas are viable. And people might say they're pie in the sky, but they're not. I mean,
That is not pie in the sky.
Exactly. We're talking proven technology.
Yeah.
We're talking we're talking available materials and something that can be delivered on at scale and managed through some kind of a regulatory framework, right? So
It could be done.
It could be done.
It can,
So
and it just
what
doesn't.
do we need to do in order to get there? Because that sounds really awesome to me. If that would solve my problem of being able to have a province full of EV charging.
Well, I think the issue everyone needs to understand is if you have, say, a place like, I'm going to use Costco, but it could be any giant box store parking lot, any giant parking lot. There's an owner of that land.
Yes, yes.
And there's usually a landlord, or sorry, a tenant of that
Yes.
land. And the tenant, and there's a building manager of that land.
Mm-hmm.
So the owner usually deploys to the building manager. Then the tenant rents that building. But like, why would they do anything other than what they rented it for?
Well, they could make some money at it.
Well, maybe. So you need a policy where that person can make money.
Mm-hmm.
But if you're a business, your lease is up maybe in 5 years.
Yeah.
It might be up in 20. But then after that, you're gone. So you need a way to ensure that if you do an investment, you make money back from it. I mean, they are a for-profit business. So you have
Absolutely.
you have to accept that they don't need to make, it doesn't need to be their core business, but you need to remove the risks of them in doing that. And they don't want, a regular business does not think like a utility. Like a utility thinks in a 100-year payback.
Right.
A typical business, probably 3 years.
Right.
They have to pay it back. So there has to be a system in place. And it's a policy problem. It's not actually a technological problem. How do you enable these people to get that installed so that you can deliver power to the people of your local area, in our case, it's British Columbia?
It seems to me if this was a solvable problem, that someone would have done it by now. Why hasn't this happened by now, Mike? Why am I not driving around? So, I'm a young man. Why am I not living in 2025, driving around in my EV car, seeing solar panels at every Costco parking lot, and every building having both solar, EV, or solar, wind, and everything else on top of it? Why are we not there?
Yeah, and I don't really know. I think it's just motivation, because I went to a conference in Amsterdam, and I saw, when we were driving down the highway, we went for a tour of this park, and we drove down the highway, and as far as the eye could see were wind turbines. We saw solar panels, and we saw wind turbines everywhere.
Yeah.
So I just
Very European.
But when I see that, I think to myself, we can't get a single wind turbine to run because it's said that or for some reason there's a barrier. But you go to Europe and you see them as far as the eye can see. Yeah. Literally as far. I wish I could just show you this picture and you can just see these huge turbines in fields. And what they've done is they've made deals with the owners of that land.
Right.
And I think in, say, Vancouver or like any large area that has huge, I'll call them stranded assets, which is parking lots, in when I'm imagining, is they're underutilized. We just use them for cars, and they're empty most of the time. So if Europe can figure out how to set up lease agreements with farmers and whoever they are so that it works for everyone, I think we can do it too.
I love that. I love the idea. I want it to be put into practice. I think that's why we're here, right? We're passionate about this subject. I mean, it's about energy in general, but this is just such an important thing for people day to day, because a lot of people are concerned about climate change. A lot of people are concerned about our energy future. A lot of people are concerned about oil and gas and the effect that it has on society. But also, obviously, there are benefits from it. We have the society that we have because of it. But we're really talking about a transition here, right?
Well, maybe. Well, I mean, it's a lot of energy.
It's a lot. Okay. So have we butted up against something here?
Well, we have. Okay, so I want to say, and there is so much energy in a cup of gasoline.
It's incredible.
There is so much energy in a cup of gasoline.
Yeah.
It's unimaginable. In fact, I'll take it one step further. There is they use nuclear power plants. People are talking about using those. The amount of energy in a little ball of uranium.
Ontario just talked about the first mini one.
That's right. They're doing these heaters.
Yeah, very cool.
And the amount of energy in that is about 1 billion times more than a cup of gasoline, we'll say.
Are unfathomable numbers of zeros.
Yeah, it doesn't matter. It just call it infinity of energy. And then we have renewable, which is not.
Right.
Right? It only works when it's sunny. It only works when it's windy.
Yeah.
There's all these other techs out there that don't work particularly well.
Yeah.
But let's just stick with sun and wind. Globally we use so much energy. Yeah. You just can't, the renewable energy is just a small fraction of what we use today. So to convert to renewable energy tomorrow is just never going to happen.
But let's not forget, I mean, we're talking solar and wind, and I think this is important for people, especially who live in British Columbia or in other provinces with significant hydroelectric capability. That is a renewable technology, right?
Yes.
I can't exactly remember the proportion, but it's somewhere high in the north 90% of our electricity in BC is from renewables.
It's from renewable, that's right? Electricity. So, the rest, the 33% of our energy in this province is used in gasoline to propel cars.
Right.
And 33% is used for heat,
so,
which is in natural gas.
So we got to talk about energy mix, because this again, now we're starting to go from the plug in our house for our electric car, now back to the fact that I'm using gas in my hybrid. I've chosen for an energy mix that works for the life I want. We're now really talking about an energy mix that works for the society that we want.
And so to convert to fully renewable, if you want it, you have to rethink the mix of fuel.
Ooh, so now this is a problem. Because this is now going to take us as a society that tends to be very focused in what we want to do. We want to make money on this. We want to do this. We want to, enact that. Now we have to try and come up with some kind of grand design to put all of these in a pot and use it the most efficiently, all these different fuels most efficiently to achieve an end goal. That sounds pretty tough, Mike.
Right. And there's a double problem.
Ugh.
There's more problems.
Engineers would always bring more problems.
No.
I mean, it sounds like we've got a lot of solutions. At least that's what I would think.
Yeah.
Though we haven't really talked about many solutions.
I'll give you a fun one. This is a fun one.
Yeah.
Jevons efficiency paradox. Technical term.
Oh, Mike, you're going to...
What is the efficiency paradox? Jevons efficiency paradox.
Did I ever learn this? I don't know.
No, you didn't. I read about it recently.
Oh, thank goodness. I thought
Yeah,
this
it's not
was like
from
a
school.
horrible test or something
No.
that I failed 20 years later.
Say we invented, you and I, passionate electrical engineers, we invented a machine that cut the amount of energy that people used by half in this area. Okay?
I'm with you.
And then we went away for a year. We patted each other on the back, and everyone used them.
Yeah.
Everybody had to buy this little thing. Everyone used them.
Yeah.
And we cut the energy in half.
Okay.
When a year goes by,
Yeah.
and we measured how much energy everyone used,
It's back to where
would
we
they
were
have
before?
used less energy?
No, it's back to where we used before.
Almost often, yes. And why?
Because we always find something more to plug in.
That's right. So when you do efficiency, what are you going to do with that? When you save in efficiency, you save money.
Yes.
And if you have extra money, what are you going to do with that money?
Spend it on things that consume more energy.
I'm going to Hawaii.
Oh, I love Hawaii.
Right?
Hawaii's amazing.
So of course you're going to go.
Yeah, no kidding.
So you're going to spend it on a ticket to Hawaii.
Yeah.
And
Which
thus
then burns more energy in my
more
airplane.
energy.
Yeah.
And planes, 1,000 liters a minute.
So, I mean,
fuel. It's a lot of fuel.
It almost sounds like we're doomed, Mike. We're not doomed, are we?
We're not doomed. I'm just saying we have to think differently. Like there's all these things people don't think
Okay,
about.
that's great. Well, and I think that's really part of what we're kind of trying to get here is that let's chuck all of these different things on the table to make sure that people's decisions, buying decisions or building decisions or anything is at least informed on the energy side. Because we started this conversation with EVs. Because that's something that is tangible in the news day to day, and a lot of people are saying we need more of it. The distributed pollution issue, that versus the single point issue, the fact that BC uses a lot of renewable energy through hydroelectric, the ability for maybe we could use some grid tie grid tie systems to renewables or standalone renewables. Like these are all really positive. But it didn't take us very long, did it, to now start to go and change our magnifying glass outward, see a whole system and go, wow, okay, this starts to need to take some really big collective steps towards understanding what our energy future, I almost said engineering future, is it because I'm looking at your Engineers Canada pin? But, engineering future, energy future is going to look like. We got to solve a really big problem.
Right, and we're not, and I think there's some things that are, I believe, this is my opinion, that are impossibles.
Yeah.
I think as a society, telling people to stop using energy is never going to happen.
Couldn't agree more, and we should.
Your health depends on how much energy you use.
Absolutely.
Your comfort depends on energy you use.
Absolutely.
Your ability to get around.
Yeah.
Right, all these things. Energy is directly related to prosperity. So commanding people to use less energy is sort of a foolish proposition.
Yeah.
However, using energy more efficiently is not, because people will use less energy.
But coupled with a plan with what to do with
cleaner energy or better made energy that's clean. Like say for example, if we could use coal-fired plants, but we could clean the carbon out of the smokestacks.
Right.
Coal's fine then. Because you're getting rid of the carbon that's going into the atmosphere.
Well, see, now two electrical engineers are starting to riff into an area.
Chemistry.
What about?
We're not chemists.
What about mining and mineral extraction and all that
I know,
kind of stuff? So
So
that
what
is one struggle with engineers is that we tend to, feel that we have answers for everything.
Yeah, we don't. But
Yeah, but we don't.
putting
But
a
it,
boundary, we're bounding our problem here.
Let's do
We're
that.
not talking.
Yeah, just make sure. Yeah,
our
we're
boundary
talking
is
about
we're not talking about
electricity.
we're not going to talk about mines.
Okay.
We're not going to talk about all that stuff because that's a totally different
Not
argument.
saying bad, but not saying good either. Not saying anything.
No, we need mines.
Of course we do. Because
mean-
we can't have the metal to make the wires
Yeah.
that we need for electricity.
Well, I got a wedding ring and I needed that. I got
I got one of those too.
right, but that's metal from the ground.
That's true.
Everything's got from mines.
So carry on with your conversation. You have to try and have a solution with a mix for the amount of energy we need as a society.
Asking us to use less energy is not going to happen. And the other little kind of global issue is there's a lot of poor countries out there that want our lives and they want to live like us.
Sure.
So humans as a whole are going to continue to use more energy. So we need to find a way to make energy in a way that's cleaner and sustainable that allows us to all prosper.
Yeah, I couldn't agree more because one of the things that has really bothered me is obviously the amount of consumption, and I think we're all guilty of it. It's our consumption far outweighs what we should or shouldn't have had. We understand that there are a lot of people in this world who don't have that energy security. Why don't we look at the fact that our consumption is out of touch? It's out of pace with our ability to be able to provide it. And obviously that then brings in sustainability, that brings into a bigger societal issue that we have that we're going to need to solve. So I've appreciated that you've taken this time, Mike, because I really enjoy learning from you. And I mean, you have a lot to give to people through your experience and the ability also for us to talk about wide-ranging, difficult topics and have a conversation about them. Because honestly, between our two firms, we're going to need to help to solve these and also then convince a whole new generation of people that these things are important and worth spending their time, efforts, and energy
That's right,
on.
in a practical way.
Yes, thank you.
Right? Like we can't just shut off the
No.
use of energy. I think there's sort of a societal expectation that we can just switch over to a
Yeah.
new type of energy, and we can't.
No.
There's infrastructure, there's gas stations, there's natural gas strung all over the place, and some of those systems are very hard to change.
Yeah.
And you just can't do things overnight, and we don't have an easy solution.
So
that can be
let's
done.
start thinking about that from the minute that we go to a EV dealership to the minute we decide that we're going to put in a bigger hot water tank just to take longer showers, or the minute we do anything that is going to impact our energy future. We got to think about how it's all going to affect the entire system as a whole. And yes, that seems like an almost impossible mandate for anyone to try and do. But obviously as a society, if we don't start, we're not going to get there. And this will then inform our conversation around EV charging, where we started this whole thing.
Yep.
And we're going to then be able to lobby for the right changes of mandates and of policies and so on, as you said, so that we can get to a place where we can be there, but also at the same time, we don't have individuals just getting to a point where they're very, very frustrated with a system that constantly seems broken.
Well, and I think the system needs a policy change.
Yeah.
So things like, why is it so hard for someone to do rooftop solar with the utility? Why are there large parking lots that don't have solar?
Absolutely.
When you go to around the world, like I said, I was mentioning at the beginning of this, I was just in China seeing the electrification that they've done so quickly of their transportation fleet. There's solar panels on every parkade. You drive through the countryside, every building has solar panels on it. So they've done as much as they can to do that, and they've done it en masse with an understanding that this serves the public interest.
Well,
so how do you do that?
Exactly. So stay tuned for more of these kind of wide-ranging topics, because with Hedgehog and MCW both committed to trying to deliver an energy future that we can all be proud of and that can work into a sustainable environment, I think we got a lot more on our hands.
Yeah, we do. And so to hear more about this, feel free to follow us. I'm at Hedgehog Technologies, www.hedgehogtech.com, or
I'm at mcw.com, or you can spot us on LinkedIn, and MCW provides a lot of interactive feedback on various topics. Check us out. We're all across Canada, and we're doing some really amazing stuff.
yeah, so if you want to keep up with current affairs, follow us, or stay tuned for more podcasts.
Thanks.